Hello, this is Milt Olson, Maintenance Technology Systems. We're here to work with our MTS Xplorer vibration analysis software package today. We're actually going to set this up and do analysis, just to give you an example of how many of the functions work. So we've got our waveform plot and our FFT plot open. As you can see, the cursors are all active in between here. I'm going to open up a couple more plots. And we do have a little bit tighter screen restrictions here, so we'll be showing you how I typically set those up. So we're going to make this waveform plot that we opened as small as possible, and we're going to stick him right up here at the top. And then we're going to select the highest reading. So we're using triaxial data from our VBox 3, and we're going to have it display the highest amplitude data of the horizontal, vertical, and axial. So you don't have to go look through that one. Our next one is going to be in our FFT plot, and it's going to open up here for us, and once again we're going to make it as small as possible as well. And we're just going to bring him over here and just kind of overlap him a little bit on the waveform plot so we can see what's going on. But we're also going to select a peak hold. What this peak hold does is it shows us the highest peak at every frequency between the horizontal, vertical, and axial on our triaxial transducer. I'm also going to knock the Fmax down here to about 4,000 hertz. So it's a little, it's about double what I'm typically looking at. And it gives us an overall of the peak hold stuff. Now the next one I'm going to open up is a demodulation plot. And he opens up, looks like this. I'm going to pull this down to about a 2,000 hertz window. And I usually run him from about 1,500 hertz out to about 3,500 hertz. That's pretty typical for me. Then we're also going to make him as small as he'll go, and we're going to place him over here on the right hand side. And he mostly fits. We're actually going to cover up that guy as well. So we've got our highest amplitude waveform, our peak hold spectrum, and our demodulation over here. There's one more I'm going to open, and it's one that we call our previous analysis window. And as you can see, that's it just shows us the date of the analysis that was done and an alarm level. I'm just going to stick him all the way over here in the corner, so all that I can see is just the alarm. So if there's an alarm, then I'll have to pull him out and take a look, and that's kind of our best option here. I want to go through all of this data over here in the left-hand column. These are the last surveyed machines, so that updated when I uploaded the data to the database. And we'll just kind of start working our way through here. It's kind of interesting. I know there's a defect coming up here in our hammer mill. So we're just going to kind of step through this. Where this gives us a little bit of a history on our waveform. It's come up a little bit in April versus last time we got this one. Looks like it was November, October before that. Same thing here with our spectrum. Not too much to look at. The amplitudes are a touch on the high side. Our overall numbers are at 0.38, 0.33, 0.26. It does appear to be trending up, and so it was a number 3 alarm. We saw something going on there, but not so much. So we'll move to the next point, which is the inboard. This one got reported on back in August of 2019 as an unbalance of the motor shaft. And we're really not seeing that much here today. It's up to 0.2, but we got some other stuff going on. And as soon as we go over across to the hammer mill side, this is a belt-driven machine, you're going to see a significant increase. Okay, you can see that we're up to 50 Gs, where we used to be significantly less. And this will show us how much significantly less it was. It's down around 4 Gs. And so that's a very significant increase since November. This machine has been off. They've been redoing this line. It's been in an outage for a couple of months. So that's kind of how that one looks. Note that we've got our spectrum here. I'm going to drop a cursor right on that. It's a 46 hertz. This is a relatively low speed, 1700 RPM motor. Stepping down to around 900 to 1,000 RPMs on the crusher shaft or the mill shaft. And I'm going to use my left and right arrow keys and watch this number right here to pick off the highest peak. 0.13, 0.09, 0.18, 0.14, And we're going to get that number all the way to 0.4 if we can find the right frequency. So I'm just using the left, there we go, the left arrow key to just move it down. I started on the high side, so I'm just moving it left. As you can see, that defect frequency we're interested in is around 42 hertz. I'm going to also bring up my harmonic cursor. Note that it hits each one of these peaks here. But note the raised noise floor. We've got noise floor of almost 0.05 inches per second. That's pretty significant compared to where it was in November. So there's that one to look at. Now we're going to go over here to the demodulation plot. Note that we've got a 10 Gs RMS overall coming out of this guy. That's really high, which once again tells us that there's something of pretty significant interest here. So we're going to put our cursor here on this first plot and see if we can use our left and right arrow keys to kind of zoom in on the highest amplitude there. There it was. There we go. 0.1125. That's pretty high amplitude there. And once again, look at this. 42.62 hertz is where our demodulation says our primary frequency is. That's what we're seeing there. The overall number is 1.2 on this particular one. Look at this. Our peak hold shows us an overall of 5.2. That is really high. Might be interesting to go to a waveform plot, play the vibration, the sound of the vibration on our speakers here, and then step back 1 month and play it again. And note the difference there. And then bring back up our current one. So that gives you an idea of what the vibration actually sounds like. Note that we've got a immediate attention that we had back on this guy in August. There's some things we certainly want to talk about. It's certainly still an immediate attention kind of vibration levels here. This is the plot I'm going to show to our customer. So I click on our report button right here. And that brings up our previous analysis back from August. This says high mill shaft vibration with some bearing defects on the drive in. This one, it's not just some bearing defects, it is definitely bearing defects. So I'm just going to take the sum out. Note that I can just free format text, or I can set up these lists and I can just select the analysis from a list, because as you go through machines, they end up being similar. I'm going to keep this one. The analysis, the vibration levels have increased. Yeah, indicating an increased energy coming from the shaft speed of the mill. This indicates unbalance of the mill shaft. No, I don't think so. So I'm going to take this last sentence or two off here, and we're just going to put in, and it's really not coming from the shaft speed of the mill, it's coming from the bearing defects on the shaft of the mill. So we're going to just edit this and put in bearing defects over here on this end. Well, it also shows a significant amount of mechanical looseness. That was not present in November of last year. Okay, we're going to totally change this. Let's see if there's something here we can modify. Copy, modify. Not so much there, and we can add this if we wanted to. The mill bearings should be changed, placed at the earliest opportunity in less than 10 days. Notice that I brought for this immediate attention. These are our different alarm levels. Let the colors change. We're going to leave this one as immediate attention. Now, another thing I can do here is I've got a spell check. So if I click on this guy, pops it up, looks at this first sentence, says spell check complete. That means it didn't find any errors or any misspelled words. We continue, it pulls up the second one, and darn, there's a mechanical not quite there. So it brings up a list of guesses here. You can select that from the list and replace that mechanical right there. You can type in here and have it do it, or you can skip it. But we want it to correct it. So there it went and corrected it for us. So we go to the next one. Spell check complete. That means it didn't find anything. We're going to continue and save. And so now look here, it updated that mechanical that was misspelled on that guy. So that's kind of a nice thing for us fat-fingered typists and so forth to use. So when I hit save, it's going to take this plot here, which is now this spectrum plot right here, which is now larger than the screen. It kind of goes off the screen. You may not have noticed that. But that's the size it needs to be to create the actual report. So I'm going to go ahead and save this. Note that my report button up here is now turned green. That means there's been an analysis stored on this machine. So there's obviously more to go through in this particular department, but I'm going to go into this report and just show you how the report part of it works. So this is kind of the back end of the analysis part. We just had to create the report. So it's going to say we've got our analysis PDF here. Is what we want to generate as a PDF sheet. I could type in my information here, MTS. Put in my name as the analyst. I could put this would be April 2020. I generate the report. It's going to come up and ask me where I'd like to store that. I don't want to put it on my jump drive. Got a little spot going over here, and then hit the OK button. So that's generating our report, and now it's complete. So I'm going to go ahead and open this file that we just created and go back to that same location here, Pilot Peak, and let's go by the date modified. There it is, right there at the top of our list. Show you what this guy looks like. There we go. So this is what our PDF file actually looks like from the report that we just created. Note the analysis that we put in there. It harvested the machine information. It kept our priority up here. Included the FFT plot, which is where we launched the analysis program from. So whichever window we launched that program from, it's going to keep that. Got our MTS, Mild Olson, April 2020 stuff here coming out at the bottom. And that's the basic process of our analysis software.